Hello everyone, welcome to Earth Archives. In the classic BBC TV series Doctor Who, there is a thought-provoking episode. A team of geologists and drillers venture deep underground and accidentally destroy the habitat of a humanoid species, the Silurians, who have lived there for millennia. These reptilian creatures were a civilization far older than humanity, possessing incredibly advanced technology. This event triggers massive upheaval on the surface, almost as if it opens a door to a world where humans were not the first civilization. What seems like just a sci-fi story has sparked widespread discussion among scientists in reality. In particular, in 2018, scientists Gavin, Schmidt, and Adam Frank proposed a theory based on this premise called the Silurian Hypothesis. This theory suggests that Earth may have once harbored a civilization older and more advanced than humanity, and that the history of our planet, as we know it, might not be complete. By studying geological records, they proposed a shocking hypothesis. The civilization we know might be just a brief segment of Earth's broader history. Is human uniqueness valid? Most people believe that humans are the first species on Earth to have developed a highly advanced civilization. With our advanced technology, rich culture, and glorious history, we seem unbeatable. From the primitive society of the Stone Age to the leap of the Industrial Revolution, and on to the rapid development of the Information Age, the history of science continually demonstrates human wisdom and creativity. However, with the increasing number of scientific studies and archaeological discoveries, we can't help but ask, are we truly the only highly developed civilization on Earth? This question has sparked countless thoughts. Through continuous archaeological excavation, scientists have uncovered many shocking pieces of evidence that suggest there may have been other highly advanced civilizations in Earth's history. We once believed human technology was unique, but in some mysterious ruins and ancient documents, it seems there are hidden secrets. For example, in the remains of certain ancient civilizations, archaeologists have found incredibly complex and advanced structures and tools that far exceed the technological level of the time. These discoveries force us to question whether other species with highly developed civilizations ever existed, perhaps similar to ours in some ways, or even surpassing us in certain aspects. Furthermore, some of Earth's mysterious phenomena have added more intrigue to this question. For example, the construction techniques of the Egyptian pyramids remain largely unexplained. Despite the huge advancements in modern technology, rebuilding a structure as magnificent as the pyramids still requires vast resources and time. How did the ancient Egyptians manage to complete such precise engineering without modern tools? Similarly, the astronomical knowledge left by the Mayan civilization and monumental projects like the Great Wall of China have also raised deep questions about the level of civilization behind them. These unsolved mysteries suggest that perhaps humans are not the only developed civilization on Earth. Additionally, some scientists have proposed the extraterrestrial civilization theory, suggesting that Earth may have had contact with alien life, and may even have had some form of communication with these extraterrestrial civilizations. In recent years, with the rapid advancement of space exploration technology, humans have continuously discovered phenomena that are hard to explain, such as UFO sightings and life forms thriving under extreme conditions. These phenomena have also led us to consider whether some external civilizations might have once existed on Earth, perhaps even coexisting with humans or other species at certain points in time. The Drake equation, estimating the potential for extraterrestrial civilizations in the Milky Way. In 1961, astronomer Frank Drake introduced the famous Drake equation, a mathematical model designed to estimate the number of extraterrestrial civilizations that might exist in the Milky Way galaxy. The core idea of the Drake equation is that the existence of extraterrestrial civilizations is influenced by several factors. The equation includes variables such as the rate of star formation, the probability that stars have planets, how life emerges, and how long civilizations can sustain themselves. By calculating these factors, scientists concluded that there may be a large number of extraterrestrial civilizations in the galaxy. This conclusion generated great interest at the time, as it prompted us to seriously consider the possibility of other intelligent life in the universe. However, the results of the Drake equation are not consistent and vary widely, ranging from just a few extraterrestrial civilizations to tens of millions. This is because our understanding of extraterrestrial civilizations is extremely limited. In fact, apart from human civilization on Earth, we have not discovered any other highly developed civilizations. Across the entire Milky Way, we have yet to find any existence that can be compared to human civilization. This phenomenon introduces significant uncertainty into the calculations of the Drake equation, leading to widely differing results. This uncertainty arises from the fact that our understanding of extraterrestrial civilizations is still in its infancy. While scientists continue to search for possible signs of alien life through various astronomical observation techniques, such as searching for habitable planets and analyzing extraterrestrial atmospheres, we have yet to find conclusive evidence of the existence of extraterrestrial civilizations. We can only hypothesize whether conditions suitable for life exist around other stars in the Milky Way, but these hypotheses still cannot fill the gaps in our knowledge of extraterrestrial civilizations. This gap adds an element of mystery to the study of alien life. We lack enough experience to judge how extraterrestrial civilizations might develop, nor can we predict how they would respond to challenges similar to those faced by Earth. Even if we imagine possible scenarios, such as extraterrestrial civilizations emerging before Earth's civilization and already having perished, or their technology being far beyond ours and undetectable by our current scientific methods, these assumptions still lack empirical evidence. The shocking discovery by scientists, the early history of life on Earth. If we shift our focus from the vastness of outer space to Earth itself, we might gain some new insights. For a long time, the scientific community widely believed that life on Earth began around 3.8 billion years ago. However, recent research suggests that the origin of life might date back much earlier, possibly as far as 4 billion years ago, when life was already present on Earth. Scientists, through detailed studies of the stromatolites in Western Australia, discovered tiny graphite specks that contained carbon isotopes consistent with organic material. This finding suggests that life on Earth may have originated much earlier than previously estimated. This research not only challenges our traditional understanding of the origin of life on Earth, but also hints at a possible truth. The origin of life might be more complex and full of uncertainties than we imagined. The birth of life was likely not instantaneous. It may have gone through multiple trials, setbacks, and even catastrophic extinctions and rebirths. This perspective provides scientists with new clues, prompting them to think more deeply about the early conditions of Earth and the process of life's evolution. The early history of Earth was marked by dramatic changes, and the disappearance and rebirth of early life became a key theme in the evolution of life on our planet. In fact, Earth experienced several impacts from small celestial bodies, which not only altered the planet's surface, but also may have posed significant threats to the birth and survival of life. Scientists speculate that after these impacts, Earth's surface may have liquefied, and the extreme temperatures could have destroyed life forms present at the time. Therefore, early life on Earth may have endured several catastrophic disasters, and may have even completely disappeared at some point. However, the resilience of life on Earth has shown us a surprising fact. Under suitable conditions, life can quickly re-emerge. This revival of life has led scientists to a deeper understanding that life is not static. It can find new opportunities in a constantly changing environment. This cyclical pattern of life and death not only proves the tenacity of life, but also offers a new perspective on understanding the evolution of life on Earth. This discovery aligns with the Silurian Hypothesis. According to this hypothesis, the evolution of life on Earth has been driven by periodic environmental changes, with each major extinction event potentially giving rise to new forms of life. These cycles of extinction and rebirth have not only shaped the diversity of species on Earth, but also influenced the overall direction of the ecosystem's evolution. Thus, the history of life on Earth is not just a linear evolutionary process, but rather a story full of multiple cycles of life, death, and new beginnings. The Silurian Hypothesis. Humans are not the only ones. According to the Silurian Hypothesis, civilizations on Earth did not emerge and develop solely through human evolution, but rather have undergone countless cycles of rise and fall. The Earth's geological cycles imply that once a civilization is extinguished, all evidence and traces of it will gradually disappear due to changes and movements in the Earth's surface. The Earth's surface continuously undergoes natural processes such as tectonic movements, volcanic eruptions, erosion, and sedimentation, which profoundly alter the shape of the land, burying the remnants of past civilizations underground or completely erasing them. In other words, the Earth seems to undergo a rebirth every 50 years, with all historical traces being destroyed or integrated into the Earth's crust. If we broaden this perspective and imagine a future civilization millions of years from now, they might, upon exploring the ruins of our cities, marvel at their fleeting nature and fragility. After all, on a geological timescale, millions of years is not long. Many structures that seem solid today, such as pyramids, modern buildings, or even our urban infrastructure, will be subjected to weathering, erosion, burial, or even dissolve into dust over these vast periods of time. For example, the pyramids of today, modern buildings, and even our urban structures will eventually be consumed and altered by Earth's natural forces over long geological timescales. The relentless flow of time acts as a tireless sculptor, gradually erasing these once great monuments of civilization until they disappear without a trace. If there were once other highly advanced civilizations on Earth, their traces may have already disappeared. The dinosaur fossils we see today are actually remnants of Earth's early life, while the traces of human civilization may only be discovered through very small fossils or artifacts in the future. Because of this, geologists and archaeologists understand that unless we find very special indicators in future geological layers, it is extremely difficult to easily find evidence of other civilizations. Even if we were to discover some tiny remnants of a civilization, we would likely be unable to accurately deduce their level of technology or historical trajectory. This is because, over the course of time, the remnants and memories of civilizations have long been erased by the forces of nature. Searching for evidence of ancient civilizations, tracing back from geological records. So, how can we search for these disappeared civilizations? The answer may lie within the Earth's geological layers. By studying different geological strata, scientists can interpret important information about the Earth's climate changes, ocean composition, temperature fluctuations, and other key aspects from different historical periods. For instance, by analyzing the ancient carbon isotope ratios, scientists have found that sudden temperature changes on Earth might be closely linked to the rise and fall of certain civilizations. While we do not fully understand the specific impacts of these changes today, they undoubtedly provide strong support for the Silurian hypothesis. A particular note, there are certain phenomena in geological history that are closely related to rapid environmental changes, and scientists are now delving deeper into these occurrences, attempting to uncover more clues. For example, high-temperature events and oceanic hypoxia events are two phenomena that might be associated with the disappearance of ancient civilizations. High-temperature events refer to rapid increases in global temperatures within a short period, typically accompanied by significant changes in carbon isotope ratios. These changes may have been caused by the release of carbon dioxide due to the burning of some form of organic matter. We know that similar situations occur in modern climate change, where increased carbon dioxide concentrations directly cause global temperatures to rise. Could past high-temperature events signify that some ancient civilizations were destroyed due to environmental changes? If these high-temperature events are connected to the rise and fall of civilizations, does this imply that the climate change issues we face today are, to some extent, a reenactment of human civilization? Looking back at history, this phenomenon might alert us to the possibility that similar environmental crises might have led to the downfall of ancient civilizations. Another environmental phenomenon is oceanic hypoxia events. Throughout history, there have been several incidents where the oxygen levels in the oceans drastically dropped, typically accompanied by rising carbon dioxide concentrations and global warming. Scientists are now closely monitoring similar signs, especially in the context of global climate warming and increasing ocean pollution. Oceanic hypoxia events occurred in ancient times and are closely related to global warming and changes in carbon dioxide levels. Do these historical environmental changes suggest that highly advanced civilizations may have existed in the past? And did these civilizations face extinction due to their inability to cope with the drastic environmental changes? How do we define the future of humanity? As we delve deeper into these scientific hypotheses, a profound question gradually emerges. If civilizations on Earth did not arise and develop just once, but have gone through multiple cycles, how should we view our own future? Will everything we do today eventually disappear without a trace in the long geological transformations of Earth? Will our technological advancements and our achievements in civilization leave an indelible mark on Earth's history? In fact, one of the key insights that the Silurian Hypothesis offers is that the history of civilization is not a straight line, but a complex, cyclical process. In these cycles, the rise and fall of each civilization are not just a reflection of the passage of time, but a symbol of Earth's and life's continuous adaptation and rebirth. If the technological progress we have made is remembered in the future, it may provide invaluable experiences and wisdom for later civilizations. Whether it's the impact we have on Earth or our exploration of the universe, all will become the foundation upon which future civilizations understand themselves. If you enjoyed this topic, please subscribe to our channel and leave your thoughts. Do you think there have ever been other highly developed civilizations on Earth? Let's discuss it in the comments section.